This is the moment everything has been building toward. Across 16 episodes, we built every piece of a production AI assistant in isolation, prompts, retrieval, tools, agents, memory. Today we assemble them into one real application, Atlas, an agentic retrieval augmented assistant that answers from a knowledge base, uses tools when it needs them, and remembers the conversation. This episode is the build, the next one ships it. Let's put it all together. Look back at the journey. We started with a single API call and a provider adapter. We taught the model to follow prompts and return structured data. We gave it a memory of your documents through retrieval. We turned it from a question answerer into an agent that can take actions. And we learned the production disciplines that keep it reliable and cheap. Every one of those was a part. The capstone is the whole and a portfolio project you can show as proof you can build this end-to-end. Here's the map of what plugs into what. The foundations and RAG episodes become Atlas's retriever. The agent episodes become its reasoning loop, its tools, and its memory. And the production episodes, evaluation, guardrails, observability, deployment become the wrapper we add in the final episode. Today we focus on the left and middle, assembling a working agentic-RAG core that genuinely runs. Atlas answers from a knowledge base, so the first piece is retrieval, the embeddings and cosine search we built back in the RAG module, packaged as a single tool the agent can call. Here's the knowledge base, the Northwind SaaS docs we've carried through the course. In the earlier episodes this came from a real loader and a vector database. Here we inline it so the whole capstone runs with no external services and no API key. The important detail is the stable ID on each chunk. Those IDs are what Atlas cites, so a user or an auditor can always trace an answer back to its source. And here's retrieval, distilled to a single function. We embed the documents once at startup, and search kilobyte embeds the query, ranks every chunk by cosine similarity, and returns the top few with their IDs. This is the entire RAG module from episodes 5 through 8, compressed into one tool the agent can invoke whenever it needs a fact. Returning the IDs alongside the text is what lets the final answer carry citations. A quick check, ask for refund, and the right chunk comes back first, with its citation ID, computed by real embeddings with no API key. The next two are weaker matches, a reminder that raw retrieval is fuzzy, which is exactly why episode 8 added re-ranking. But the top hit is solid. The thing is, retrieval alone just hands back documents. To actually answer multi-step questions, Atlas needs to reason and act. That's the agent loop, and it needs more than one tool. Notice a subtle but important shift. In the basic RAG of episode 6, we retrieved on every single query, no matter what. By exposing retrieval as a tool, we let the agent decide when to use it. A greeting or a pure calculation doesn't trigger a pointless search, a product question does. That judgment saves latency and tokens, and it's only possible because the agent, not a fixed pipeline, is in control. The same tool wrapping turns any capability, search, math, a database into something the model can reach for when, and only when, it helps. An agent is only as capable as the tools you give it. Alongside the retriever, Atlas gets a calculator, and the registry pattern makes adding more trivial. The calculator parses the expression into a syntax tree and walks it with a whitelist of operations. Critically, it never calls eval because the agent's tool inputs come indirectly from a model and ultimately from users, and you must treat them as untested, exactly as we argued in the guardrails episode. The tools registry is just a dictionary mapping names to functions, so giving Atlas a new capability is a one-line addition. Here it is working. 10 times 29 is 290, 100 divided by 8 is 12.5, and, crucially, a malicious input that tries to smuggle in real Python is refused with an error instead of executed. That second line is the whole reason we used an abstract syntax tree instead of AVL. A tool is an attack surface. The moment you give a model the power to act, you inherit responsibility for what that action can do. Build every tool to fail safe. A few rules make tools production grade. Validate every argument, because the model will eventually hand you something malformed. Never feed agent-supplied strings into AVL, executive, or raw SQL. That's the injection door from episode 14. When a tool fails, return a clear error string as an observation rather than crashing, so the agent can read it and try again. And prefer tools that are idempotent and light on side effects, so a retry can't do damage. Tools are where an agent touches the real world, so they're where most of the safety work lies. Now the heart of Atlas, the loop that decides whether to call a tool or give the final answer, over and over, until the question is solved. This is episode 9, made real. Here's the full shape. A question enters the agent loop. On each turn the model looks at the conversation and the scratchpad and decides, call search kilobyte, call the calculator, or answer. Tool results flow back in as observations, the loop continues, and memory threads the whole conversation. In the next episode we wrap this in guardrails and a streaming API, but this core is what actually thinks. The loop runs on a strict contract, straight from the structured output episode. On every turn the model must reply with exactly one JSON object, either a tool call with an argument, or a final answer with citations. No prose, no ambiguity. This single constraint is what makes an agent reliable. The parsing never guesses, because the model is forced into one of two clean shapes. And here's the loop itself. We build a prompt from the system contract, the conversation, the question, and the scratchpad of everything done so far. The model reasons and returns its decision. If it's a final answer, we're done. If it's a tool call, we run the tool and append the result to the scratchpad as an observation, then loop. Reason, act, observe, repeat, with a step budget so it can never run forever. That's the entire engine of agency, in a dozen lines. What makes this powerful is that we don't script the steps, the model chooses them. It decides which tool to reach for, in what order, and when it has enough to answer. A question that needs a lookup and then a calculation just works, because the loop keeps going until the model is satisfied. The scratchpad is its working memory within one question. And the step budget is the safety rail every agent needs, so a confused model degrades gracefully instead of spinning forever. One question is an agent, a conversation is an assistant. The last piece is memory, threading previous turns back in, so follow-ups that say that plan or it actually resolve. Memory here is deliberately simple, because the principle from episode 1 still holds. The model is stateless, so we remember for it. On a final answer we append the turn to a running history, and the caller passes that history straight into the next call. Now that plan in a follow-up has the context it needs to resolve. Episode 12 showed how to persist this across restarts and summarize it to fit the window. The core idea is exactly this thread. Enough pieces, let's run the whole thing. A multi-step question first, then a follow-up that only works if memory is doing its job. Here's what we expect. The first question needs a fact and a calculation, so Atlas searches the knowledge base, gets the per seat price, and produces the monthly bill with a citation. Then the follow-up, does that plan support SSO? Has no plan named in it at all. Only memory of the first turn lets Atlas know that plan means pro. Let's see it actually happen. And there it is, a genuine run. Atlas chose to search the knowledge base, found the $29 per seat price, and answered with the computed $290 monthly total, citing the source. Interestingly, it did the simple multiplication itself rather than calling the calculator, a reasonable judgment for easy arithmetic, with the calculator still there for anything harder. The agent decided its own path. Now the real test. The follow-up never says pro, it says that plan. Thanks to memory, Atlas knows exactly which plan we mean, searches for SSO, and correctly answers that pro doesn't include it while enterprise does, with a citation. Retrieval, Tullius judgment, multi-step reasoning, and memory all working together on a real conversation. That is the agentic-RAG assistant, assembled and alive. Step back and see what you have, a genuine agentic-RAG application, built from parts you understand line by line. A retriever exposed as a tool, a registry the model draws from on its own judgment, a reasoning loop that handles multi-step questions, and memory that turns isolated answers into a conversation. There's no framework magic here, you could rebuild every line. That understanding is exactly what makes you an applied AI engineer rather than someone who pastes from a tutorial. And notice the scene we kept. The model step is a single function, call model, prompt in, text out. To move from the Claude CLI to the Real Messages API, you change that one function and nothing else. Route it through the chat adapter we built in episode 1, and switching providers entirely is a one-line change. Atlas is powerful, but it's never locked in. In the final episode, we'll prove it with a live Claude to OpenAI swap, right before we deploy. Because tools live in a registry, growing Atlas is genuinely a one-line affair. Want it to answer from your live database? Add a validated, read-only SQL tool to the dictionary. Want current information? Add a web search tool. The agent loop and the system prompt don't change at all, the model simply sees the new capability and starts using it when it fits. That clean separation between the loop and the tools is what lets a real assistant grow from 2 tools to 20 without the core ever getting more complex. Here's why this matters beyond the code. Atlas is a real project you can run, show, and most importantly explain. In an interview, anyone can demo a chatbot, very few can walk through why retrieval is a tool, how the agent loop terminates, where injection is blocked, and how memory threads a conversation. You can because you built each piece from first principles. That depth is the difference between using AI and engineering with it. In the final episode, we harden Atlas into something you'd genuinely put in front of users. Recap. We assembled the whole build half of the course into Atlas, a retriever, a tool registry, a reason act observe loop, and memory, and watched it solve a real multi-step question and a follow-up that depended on remembering. Every line is something you understand and could rebuild. In the final episode, we make it shippable, guardrails, evaluation, observability, and a streaming API, plus that live provider swap. We've built the assistant, next, we ship it. See you there.